Representational state transfer is a set of concepts used to facilitate data communication. That communication usually happens through the HTTP protocol. RESTful APIs are widely used for modern distributed systems, and most notably client-server applications. Building a scalable REST architecture requires careful analysis, design, and prior knowledge of the industry best practices. In this video, I've carefully selected a list of tips to help improve the quality of your REST architectures. We will first discuss URL structure and word usage. The main building block of a REST API is called a resource. A resource is simply a piece of data or a service. There are different types of resources. The first type we're going to talk about is called a collection. A collection is simply a set of other resources that's usually grouped by the API server. We'll use a simple movie database API example. In our example, the movies collection is a set of movie documents. A collection contains document resources which represent a single database record. The following will retrieve a single document resource, a movie with ID 1. There is another resource type called a store. The store resource type is similar to a collection because it also contains a set of documents, but it's created by the API user rather than predefined by the API server. An example for this would be a user-curated list of favorite movies. The last resource type is called a controller. A controller resource is similar to an executable function. It has inputs and outputs. It's used for actions that cannot be mapped directly to the CRUD operations that are covered by the standard HTTP methods, like get, post, put, and delete. Now we know the 4 types of resources, and we can formalize a good URL structure. It should follow the following design: a collection, followed by a document, and lastly, a controller. If there is a store resource type, it can usually replace any collection in this URL template. This pattern can also be repeated multiple times to browse in depth. Only the controller cannot be repeated, as it cannot have any children. It's not a collection, but rather an executable function. Note that providing several levels of depth can become difficult to maintain, so I would not recommend it. Instead, the API client can make several requests to get the same data. Word usage also depends on the resource type. Stores and collections should use plural words, while documents should use singular words. Controllers, on the other hand, should always use a verb. The next tip we'll talk about is versioning support. Ideally, the REST architecture should allow you to add new major versions without breaking the functionality for users of the old versions. It's best if you take this into consideration before releasing version 1 of the API. The most popular way to handle versioning is to add the major version in the URL. Another method is to send the version as a query parameter. I find the first method more readable than a query parameter, but you can use both. The most important note is to take versioning into consideration during the design phase. A RESTful API is usually built on top of the HTTP protocol. A good RESTful architecture utilizes the functionalities of the HTTP protocol fully. This means you should not create a custom controller resource for any of the CRUD operations, as they can be covered by the HTTP request methods. Besides the most popular 4 methods, post, get, put, and delete, we also have patch, head, and options. Here is an outline of what these methods are meant to represent. Post creates a new document, while get retrieves documents. Put updates a document with the provided properties, and the object should include all properties in the document. Patch is the same as put, but it can include a single property in the body instead of all properties of the document. Delete deletes the document. Head retrieves header information without a body. Usually that means the same data as get but without the document. Options retrieves resource metadata. Usually that returns about HTTP methods for the resource. In addition to request methods, the HTTP protocol supports useful status codes. They are 3-digit integers that indicate the status of the response. The 200 status codes indicate success. 300 codes indicate redirection. 400 are client errors, and 500 are server errors. There is a larger list of HTTP status codes linked in the description, but the ones shown in this slide are the most frequently used. HTTP status codes are a great protocol level indication to the API user on the status of their request. You should use them in every response. HTTP status codes are not enough to convey an error message. Ideally, the API should provide detailed error messages. As the recipients of these error messages will be end application users and developers, It will be best if you provide two separate messages for both entities. With two separate error messages, the API client can display the user message to the end user, and the developer can use the other message to troubleshoot the issue. The next tip is to use query parameters to optimize the responses. In a real application, collections can become quite large. Retrieving all documents in every response is not efficient. Your application should provide functionality to filter the results, and this can be achieved through query parameters. Pagination is frequently implemented, and it can be designed using the limit and offset query parameters in the API request. Limit denotes the quantity of items to retrieve, and offset is the index of the page. In this case, the Movies API will retrieve 10 movies from page 1. Classic filtering can be more complicated, as you may want to exclude items based on different conditions. The simplest option to implement filtering is to use the query parameters to define the values of the filters. This is not great for two reasons. First, field names can be in conflict with query parameters used by the API. Imagine if we have pagination and at the same time a limit field in our document. Second, this only allows us to do simple filtration by field values, but sometimes more complicated logical expressions are needed. A more sophisticated solution is to use a querying language as the value of the filter query parameter. Sorting is also frequently needed. A good sorting functionality supports sorting by multiple fields in ascending and descending order. One solution is to list the fields to be sorted in the value of the sort parameter and prefix them with plus or minus for ascending or descending. Finally, to optimize the payload size, it would be great if the API provides the user with an option to choose specific fields to retrieve from a document. A common approach is to list the fields to retrieve in the fields query parameter. The final tip is to use hypertext as the engine of application state. It's a mouthful, I know, but let me explain what it means. Ideally, a REST API should allow navigation through the resources, without having an external resource or documentation to provide you with all of the endpoints. This is achieved with links in the responses. They are especially helpful for public APIs. If you're worried about the overhead affecting performance, you can introduce a query parameter to disable them. I carefully selected these specific tips because they are either fundamental or frequently overlooked. If you apply all of these, you will achieve a more scalable and maintainable RESTful architecture.